welcome to this explainer. So, if you've ever stood in a city and just looked up at a massive modern skyline, you are quite literally looking at millions of tons of extracted stone and cement. But, we rarely stop to think about where all that material physically came from in the first place. Today, we're going to unpack the intense physical life cycle of a quarry, and more importantly, how global sustainability standards actually measure its massive impact on the Earth.
Right, let's dive straight into this by asking what I think is the absolutely crucial question. What exactly happens to local ecosystems when we extract the building blocks of our cities? Because there is a massive, often hidden ecological footprint behind the cement and stone that build our modern world. It's just an undeniable reality that getting these construction materials requires unearthing natural resources on a staggering scale. But how do we track that footprint? How do these companies actually account for the land they disrupt? To understand this chronological journey, we're going to walk through 4 quick phases. 1, the impact of quarrying. 2, permanent landscape alterations. 3, environmental management plans. And finally, 4, decommissioning and site restoration.
Okay, section 1, the impact of quarrying. We have to start right at the beginning, at the physical site where our construction materials are quite literally born out of the earth.
Now, our guide for this explainer is a really fascinating document. We're drawing our insights directly from the SASB Sustainability Accounting Standard for Construction Materials. And what I love about using this specific source is that it's literally an accounting standard. It tracks how companies must officially report on these incredibly intense extraction activities to their investors. So we aren't just talking about, abstract environmental ideas here. We are looking at how ecological impact is measured as a hard operational reality. The standard outlines that this extraction necessitates tearing up the earth in 3 highly disruptive steps. Step 1, you have to completely remove the vegetation and topsoil. The ecosystem is just stripped right back. Step 2, blasting the underlying stone deposits. This is brute force explosive extraction. And step 3, crushing that stone into usable material. It's an incredibly intensive, violent process right out of the gate. Which brings us to section 2, permanent landscape alterations. Let's see how this intense extraction builds into a long-term problem for the surrounding environment. Because obviously, once you've blasted rock out of the ground, you can't exactly just glue it back together.
And the official standard explicitly recognizes the severe, enduring consequences of these activities. It literally notes that the process can result in permanent landscape alterations. This isn't like a temporary downtown construction site where, the scaffolding eventually comes down and everything goes back to normal. No, a quarry permanently changes the physical topography and the biodiversity of that area. So how do you measure a permanent alteration like that? Well, to track this impact, companies actually have to quantify what the standard calls their disturbed land. Think of this as a massive running tab, measured cumulatively in hectares. It represents the total footprint of the quarry from the absolute moment they arrive, during exploration and development, straight through production, closure, and even post-closure. Literally every single hectare they touch goes onto the balance sheet as disturbed land. And because of growing global awareness around biodiversity, trying to set up a quarry in ecologically sensitive areas presents massive financial and reputational risks for these companies. Say a proposed quarry site sits on a critical habitat for an endangered species. Ecosystem protection laws kick in immediately. The standard highlights that this can significantly increase extraction costs and create major regulatory barriers, potentially blocking new sites altogether. So the environment absolutely dictates the economics here. Let's move to section 3, environmental management plans. The really crucial point here is, how do companies actually mitigate this massive disruption to local biodiversity while still giving us the materials we need to build? Well, to stay compliant and protect habitats, active sites absolutely must have rigorous, comprehensive environmental management plans. And these plans have to address a really wide array of severe operational impacts. It's not just about managing the giant physical hole in the ground. They have to account for the ecological and biodiversity impacts, sure, but also waste generation, the sheer deafening noise of the blasting, emissions being blown into the air, discharges leaked into the local water supply, natural resource consumption, and the use of hazardous chemicals. It is a massive, massive logistical and environmental undertaking. Furthermore, companies are expected to align these management plans with strict global benchmarks, specifically the International Finance Corporation's performance standards. As you can see, these standards cover everything from pollution prevention to community safety. But Standard 6, That is the real heavyweight for our topic today. It covers biodiversity conservation and management of living natural resources. It fiercely protects areas supporting endangered, endemic, or migratory species. Basically, if a company's plan doesn't align with these high bars, they are seriously falling behind the industry standard.
Finally, we're at Section 4, Decommissioning and Site Restoration. Let's explore what happens when the stone actually runs out and the quarry reaches the end of its productive life. What exactly happens to all that disturbed land on the balance sheet? So, a company's environmental management plan isn't just for when the giant machines are running and rock is actively being crushed. No, the plan must span the entire life cycle. It starts at the pre-bid and exploration phase, way before they even break ground, and it extends long past production, ending with strict closure, decommissioning, and finally post-closure restoration phases. The environmental responsibility absolutely doesn't end just because the profit stops.
Which brings us to the ultimate environmental ledger for any construction materials company. Success here is tracked by balancing two major accounting metrics required by the SASB standard. On one side, the terrestrial land area disturbed. On the other side, the percentage of that impacted area that has been actively restored. It's this incredibly direct visual comparison of the company's ecological debt versus their actual ecological repayment.
But we have to ask, what actually counts as restored? They can't just, plant a few scattered trees, throw down some grass seed, and walk away. Restoration has a very specific, highly rigorous definition, cited right in the standard from the Society for Ecological Restoration. It is defined as the process of assisting the recovery of an ecosystem that has been degraded, damaged, or destroyed. It is all about genuine ecosystem recovery. It requires intense scientific effort to rebuild that complex web of life that was violently removed during step 1. And honestly, here is the rule with the most teeth. Land is no longer considered disturbed only once post-closure restoration and remediation efforts are substantially complete. That is the ultimate goal here. That massive cumulative footprint of disturbed land we talked about, it literally stains on the company's public reporting books as a glaring liability until the ecological recovery is practically finished. They are held publicly accountable until the earth is actively healing. It really makes you look at our built environment totally differently, doesn't it? Knowing the immense ecological debt, the incredibly rigorous standards, and the required scientific restoration tied to every single brick and block, it completely changes your perspective. Next time you look at the concrete and stone in a modern building, ask yourself about the quarry it came from and the active ecosystems that had to be carefully managed and eventually restored just to put that building there. Thank you so much for joining me on this explainer today. Keep learning and stay curious.